Okay, done with question 21, last question of this exercise, and then the challenge questions, chapter 8 that is. Let's have a look at question 22 to finish up. Okay. G of x is 4 plus kx squared, x to the power 5. So g of x is equal to 4 plus kx to the power 5, where k is a constant, given that the coefficient of x to the 3 coefficient is equal to, in the binomial expansion of gx, is 20. Okay, find the value of k. Okay, so if we did the first expansion, we would get x, so we would get the constant, then we get x squared, then we get x squared, x to the power 3. So that's going to be 5 to the power, it starts off at 0 for the constant, 1 for the x, 2 for the x squared, and 3 for the x cubed. Then we need to look at the 4. The 4 would have been started on 4 to the power 5, and then it would have been 4 to the power of 4, 3, 2, 1, etc. as we go down. So from the 0 has 5, the 1 has 4, 2, 3, so we're on 4 squared. Okay, and then counting these up, 0, 1, 2, 3 is to the power 3, isn't it? K x to the power 3, of course. So 5 to the 3, 5 NCR 3 is 10, 4 squared is 16, and k cubed x cubed. Okay, so that all equals 20. 10, 16, k cubed. Don't need the x cubed on there because I don't have the x cubed on the left here. So the 10 and the 20 will obviously cancel, give me 2. So I end up with 2 divided by 16. By the time I divide by the 16, give me k cubed. 2 divided by 16 is, of course, 1/8, and the cube root of 1/8 is 1/2. Okay, so the cubed root of 1/8 is equal to k, meaning k is equal to 1/2. Now on to the challenge questions. Challenge question 1, f of x equals 2 minus px and 3 plus x to the power of 5, where p is a constant. There is no x squared term, or the coefficient is equal to 0. Okay, in the expansion of f of x, show that p is 4/3. Okay, so how are we going to get the x squared term? Obviously, this will produce an x squared term, which we could find, but multiplying it by this will not give us the x squared term. So we could expand all of this and then just start multiplying it by 2, which will double it up, and then multiplying it by p, which means we get every other one, which I think might be the safest way of doing this one to begin with. Okay, or what you could do is you could take this 3 plus x to the power 5, you could find the x term for it, you could find the x squared term for it, and then when you multiply it through, you would then just have what you need to make all of the x squared term. So let's show you what we mean. Let's work on first 3 plus x to the power of 5. Okay, so as we've done before with the Fibonacci or Pascal? It's Pascal, isn't it? Pascal triangle. If we start with 1, 1, 1, 1, 2, 1, okay, that's your x squared at that point. And obviously x to the power 3, x to the power 4, and x to the power 5. Okay, and we end up with 1, 3, 3, 1, 1, 4, 6, 4, 1, and then 1, 5, 10, 10, 1. Okay, so instead of doing 5, 0, 5, 1, 5, 2, 5, 3, 5, 5, etc., okay, we've just done it out here with the Fibonacci to keep it simplified. So here's 1, 5, 10, 10, 5, and 1. I've written it wrong over there, haven't I? It doesn't matter. Okay. And then as you start coming down here, you have times 3 to the power 5, 3 to the power 4, 3 to the power 3, 3 to the power 2, 3 to the power 1, and eventually 3 to the power 0. And then you have x to the power 0, x to the power 1, x to the power 2, x to the power 3, x to the power 4, and x to the power 5. Okay, and all of these terms here are multiplying each other together. Okay, so I think I'll just put this middle one inside brackets like that. Okay, so what do they all come out as? All right, 3 to the power 5, okay, is 243. Okay, 3 to the power 4 is 81 times by 5 is 405. And then 3 to the power 3 is 27 times 10 is 270 x squared, and then 90 x cubed, and then 15 x to the 4, and finally x to the 5. Now each one of these terms still needs to be multiplied by 2 minus px, okay, which will obviously give us a double of it, multiplying it by 2, and also it will give us an increased value of the power of x, because it's multiplied by px. So 243 times 2 is 486 minus 243 px, and then we're going to have 810 x minus 405 px. Then we're going to have 270 times 2 is 540, 540 x squared, okay, minus 270 x cubed. Okay, snuck in a sneaky squared just up there because I forgot to multiply the x's. Okay, and as we come down here, 180 x to the 3 minus, got my p up there, minus 90 px to the 4, okay, and then 30x to the 5 minus 15p x to the, there, that should be 4, shouldn't it? That one should be 4, that one should be 5, okay, and then finally 2x to the 5 minus px to the 6. Now, as we go through this, we can see that as we start collecting these terms, obviously that is an x squared term, and that is an x squared term. Nothing else is an x squared term. And we're talking about the coefficients of them. So if we take minus 405p, add it to 540, that will equal 0. Okay, so p is equal to 540 divided by 405. By the time you rearrange that, 540 divided by 405 is 4/3. Which is what they asked us to show it was. Okay, good. Question 2 on the challenge then. Find the coefficient of x squared in this. Wow, there's a lot in that. Okay, so they want to know what the x squared coefficient is when you have 1 plus 2x to the 8 multiplying by 2 minus 5x to the 7. Don't particularly want to multiply it all out because that is going to take too long. So we need to start thinking about where the x squared term for this is going to come out of. Obviously, there's going to be an x squared term come out of this 1 to the power of 8. There's also going to be an x squared term come out of this 2 minus 5x to the power 7. And both of those terms will get either multiplied by the 2 or the 1, depending on vice versa where they came out of. Okay. We're then going to have the x term of both of them, multiplying the x, just of x to the power 1 term out of both of them, multiplying together to give us an x squared term. And I think that should be all of them. So let's have a look and see what we can do. So we are going to have 8 to the 0. That's my constant on here. Then I'm going to have 8 to the 1. To the 1, and I'm going to have the 8 to the 2. Okay, and inside there I'm going to have 1 to the power of 8, 1 to the power of 7, 1 to the power of 6, and here I am going to have 2x to the power of 0, and I'm going to have 2x to the power of 1, and I'm going to have 2x to the power of 2. And some other bits and pieces. And all of that is going to be multiplying 7 to the 0, 7 to the 1, and 7 to the 2. And that is going to be multiplying by 2 to the power 7, 2 to the power 6, and 2 to the power 5. And then that's going to be multiplying a minus 5x to the 0, a minus 5x to the power 1, and a minus 5x squared, which is going to be multiplying everything on the left. Okay, let's just quickly get those numbers out. All of that is just 1 for that first one, plus 8 to the 8 NCR 1 is just 8 times 1 times 2, so 16, because it's the 2 here and the 8 here, giving me 16x plus NCR 82, so 8 NCR 2 is 28 times the, now it's going to be 2 squared, which is 112 x squared. Okay, so that's the 28 times the 4 from the 2 squared here. Okay, and all of that plus some other stuff which will be like x cubed, which isn't going to do anything good when I'm multiplying to try and find an x squared coefficient. Okay, on this side, the first term here resolves to 2 to the power 7, okay, which is 128. This is going to be a minus to begin with. Okay, it's going to be 7 NCR 1 is 7, 2 to the power 6. 2 to the power 6 is, of course, 64 times 7 is 448. 8 x 7 NCR 2, all right, is 21. 2 to the power, so this one's 21. 2 to the power 5 is 32. 32 times 21 is 672 times the 25 for the minus 5 times minus 5 here, okay, times 25 is 16800. 16800 x squared plus ... Okay, so now as I come out here, I'm going to multiply this 1 to get a 16800 x squared. I could do it as 128. I could get all of this, but I'm definitely going to get that one. I'm then going to have the 16 multiplying, which will only produce an x squared when it multiplies here. Okay, so I'm going to do the 1 and the 16,800. I'm then going to do the 16x with the minus 448x, and I am going to be doing the 112x squared times 128. Okay, so that I get all of the x squared terms coming in. Anything else after that will be multiplied by an x cubed, which would give me 128x cubed and whatever the coefficient was here, which is all clearly bigger than x squared in terms of its powers. So from the yellow ones there, okay, let's have 16,800 x squared. Then from the green ones here, 16 times 448, so 16 times 448 is 7,168, and it's a minus 7,168 x squared, and then we've got 112 times 128 for the pink ones there, which is 14,336 x squared. And all of those will obviously add together to give us the final x squared coefficient. So 14,000 plus 16,800 gives me 31,136. Take away 7,168 gives me a final total of 239,68. Okay, so the coefficient, find the coefficient of the x squared in the expression. Yep, that should be it. So you no doubt heard the distraction in my voice and wondered why this is giving me a different answer, okay, to what's in the back of the book. So the 7168 here is wrong because the 448 is wrong. Okay, so what happened here? We had 7 times 2 to the power 6, which is 64. And when you multiply them, times 64 is 448, like we had. But I didn't multiply by the minus 5, which gives us 2240. Now we need to multiply that by the 16, times the 16 gives us 38540. Okay, so the new term down here becomes 35840, and then when you do your 16800 plus your 14336, giving you 31136, take away your 35840, you end up with minus 4704. Okay, so do watch out as you go through everything. Even after doing 20 of them, little mistakes can still happen. Okay, chapter 9 next.